Hello, this is the sixth and final class on derivatives, derivative six. So what we've done so far is limits and then a bunch of derivative stuff based on the delta process. And we've done the power rule, constant rule, product rule, quotient rule, chain rule, mixed derivatives, which is just a mix of the rules. We've done higher order derivatives, which is getting more than one derivative. It's very simple, actually. First derivative, second derivative, third derivative, fourth derivative, and so on. And finally, we have talked about the tangent and normal lines. And that was the last thing we did yesterday. So I'll just scooch back up here and just briefly review. The tangent line is where it just touches the curve at one point, just touches it once and moves on. The normal line is the exact opposite. So if the tangent line were straight up, the normal line would be perfectly horizontal. It's perpendicular to the tangent line. And it's just a way of knowing, in fact, it's actually difficult to come up with a practical application that will make sense to you right now, but there are useful reasons for knowing what the perpendicular to the tangent is. We just don't get into it in this course very much. So to get the tangent line, we follow three steps, which we did yesterday. We get the derivative, we sub in our x value, and then we use y equals mx plus b. To get the normal line, we do the exact same thing. We get the derivative, sub in x equals 2 and use y equals mx plus b, but there's one extra step in the center here. We need to get the negative reciprocal of the slope, which means when we get our m value, our slope value for the tangent, you flip it over, change the sign, now we've got it. We're going to jump right into doing this question, this next example, which is on page 50. Right after that, I'm going to move into the final topic of this unit, which is rates of change. So velocity and acceleration. That one's really easy. Students always enjoy that one because it's so easy. So this is the last question, I think, if I recall correctly. This is the last example we'll do for the normal line. It says find the y-intercept. So find b for the line that is normal to the curve y equals 2x minus 1 over 3 x cubed, where x equals 3. Okay, so we need to do our regular process, derivative, substitute, get our m, and so on. But in this question, we aren't given a y value. So it's a good idea to start. So I'll say before, I've got my pen made too big again. So I'll say before we start, find our y value. And that'll hopefully become more clear later. What I mean is we're only given x, we're not given y. So I'm going to say when x equals 3, y equals 2 times 3 minus 1 over 3 x cubed. Oops, 3 cubed. And I got that from here. I'm just taking the original formula. I want to know what the y value is because I'm going to need it later. We always need that when we do y equals x plus b later. So if we solve that, we get y equals what? 6 minus 9, which is negative 3. So the reason we got that is we now know we have a point, which is actually 3, negative 9. That's our x value and our y value. So I gave you a hint on the top of the page here. It said hint, find xy first. And now we have xy. You'll see why I did that later. We could have done it at a later point, but I wanted to get it right out of the way so that we can do our regular process. So we need the y-intercept of the line, but in other words, we need the equation of the line. So the first step is to get the derivative. So how do we get the derivative? We do it directly. The derivative is, let me see if I can get away with making a bigger pen today. The derivative, y prime, is 2 minus, let me make a note here, the derivative of 1 over 3 x to the power of 3, if the 3 comes down, it becomes 3 over 3 x squared, which is just x squared. So if there's a fraction, it just deletes it out. Ayesha, you said is, I'm very sorry. The y value is -3. I just made a silly mistake because I was thinking of something else. Thanks, Aisha. So we'll come back to that later. So the whole point is if you have 1/3 and the power is 3, that fraction is just going to cancel, which means the derivative is just 2 minus x squared. Why did we get the derivative? Well, we need the derivative because we need to get the slope. So when x equals 3, maybe I'll write it a different way. I guess it doesn't really matter. I'm just looking at my previous questions. I want to make sure that I've done you well. Okay. The derivative when x equals 3 is 2 minus 2 squared. That's 2 minus 4, so we should get what seems to be -2. At least according to my calculations here. Wait. I'm sorry. 3. I don't know what's going on in my brain today. I'm going to get it back. Okay. I'm awake. I'm awake. When x is 3, we put a x value in, of course, of 3. This is 2 minus 3 squared, so 2 minus 9, so -7. What this means, and I'll put it very clearly here, as clearly as I can, this is m. So slope, or m, of the tangent is -7. That means that the slope of the normal line is what? Well, we need to do two things. We need to get the negative reciprocal. We make it negative. It's already negative, so it becomes positive. And we flip it. It becomes 1/7. Is the negative reciprocal. Change the sign, flip it over. Of course, 7 is 7/1. If you flip it, it becomes 1/7. And you add a negative. That would be if it was +7. Okay, so that's our two steps. The second step was sub in x. Our third step is our negative reciprocal. Our fourth step is to use y equals mx plus b. And this is why I got my y value earlier. I want to substitute in to this equation, y equals mx plus b. My y value, let me try to match this up. My x value is going to be 3. I'll make it purple because I haven't used purple yet. X equals 3. That'll be my x. My y value will be -3. My m will be this one. And I'll be good to go. So I have -3 equals 1/7, 3 plus b. If you solve that, it'll be -3 minus 3/7, which is -24/7. We've done this before, which is why I'm not really explaining as much as I normally would. We did the derivative, we subbed in x, we got an m. The third step is the new step. And then our fourth step is the same as before. We're actually done this question because we've solved for the y-intercept, which that was the question. But we might as well finish and write out the full equation. So we'll say if asked, the equation is y equals mx plus b, so 1/7 x minus 24/7. Okay, any questions on any of the steps besides my silly little mistakes in the middle there? I feel like we've probably done like 5 or 6 of these at least now, maybe more. So I would expect one on the assignment or the test. Let me give you a hint. I would expect a tangent line, maybe, who knows, maybe a tangent line on the assignment. And perhaps if I were, you know, a betting man, I would say that perhaps on the test you will get a normal line. But who knows? I'm just the instructor. What do I know? Okay, so that's how you get the normal to the curve. So I'm just going to compare it to the previous question. Actually, I'm going to do what I always like to do, which is I'll graph it so you can see what we just did. And this will be the last time I graph a normal line. But it's very important, in my opinion, to know what we're doing, to actually see it, what it means. So what we're going to do, I'm going to graph the original function, and then I'm going to graph the normal line, and we'll see that it's perpendicular to the function at that point. So my original function was 2x minus 1 over 3 x power 3. All right, that's our function. Our point is 3, negative 3. So that's good. That's a point on the function. So I know that my x and y value is actually okay. And now what am I going to graph? I'm going to graph that final line in the box at the end of this question here. I'm going to graph the normal at that point. So if I had to guess, if I had to draw this, I would say this is my tangent line. You know, it's a bad example, but it's close enough. And I would say my normal line probably looks like this. My purple line, that would be what I'd expect my normal line to be. It'll probably be a little more flat, actually. So let's type it in. Y equals 1 over 7 x minus 24 over 7. There we go. So this is how you check your work, all right? It asks for the normal line at the point 3, 3. That is the normal line at the point 3, 3. If you zoom in on it, what you'll notice is that they're perpendicular. My original function in red and the new function, my normal line in green, are perfectly perpendicular to each other, which means it's normal to the graph. Okay, that's what we did. That's how this stuff works, and that's how you can check your work. There's no reason why all of you shouldn't be able to use Desmos. You could do this on a graphing calculator too, but it would take longer and look worse. So why not use Desmos? Okie doke. I'm going to move on to the practice section. Let's see. Practice 1, I'm going to cancel altogether. I'm just going to say this is a big challenge. We could do this question, but you'd have to notice it says find the equations of the tangent and the normal lines to the parabola with a vertex at 0, 3, a focus at 0, 0, where x is 1. You would have to build the parabola first, and then you would have to get the derivative of it, and then you'd have to get the tangent line, you'd have to get the normal line. Way too much work. It's not appropriate for this level of math. All right, you can try it as a challenge, but I would never, ever, ever ask about the test. So let's maybe do one more practice, just so we're clear. Which one? 2 or 3? They're both the same. I'm going to ask you to do it and give me the final answer. Which one do we want? 2 or 3? 2 or 3? 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2. 2, 3. Okay, let's do 3. Abdullah beat you to it. So let's try 3. Okay? 2 is similar. 3 is a little bit simpler in a way. Actually, they're both equal difficulty. So take 2 or 3 minutes. Follow your 4-step process for the normal curve. As soon as I see an answer in the chat, I'll show you what my answer is. Okay? So let's work on it and send me your answer in the chat. Maybe once I get 2 answers in the chat, I'll move on. That's not right, Ahmed. Yeah, so Nasser and Juma, you both got it right. Tarek, you came close, but your y-intercept is wrong. Aisha, your answer is also right. So I'll reveal my answer. This is what I have. My derivative, negative 3x squared. When I substitute, let me do the fancy way, shall I? I love this function. So what I did, derivative, y equals 3x squared. Second step, sub in x. So put in x there, negative 1, and then that gives us negative 3. Most of you got that right. You took the negative 3, you flipped it over, you made it minus. It's already minus, so that makes it plus. That means 1 over 3. The fourth step, use y equals mx plus b. I think that's where some of you had the trouble. I'm going to put in my y value, which is 9. I'm going to put in my x value, or sorry, my new m, which is 1 over 3. I'm going to put in my x value and then solve for b. That's 9 plus 1 over 3. If you do 9 plus 1 over 3, it's 28 over 3. Final answer is this. Put it all together. And just as a little added bonus, I graphed it on Desmos just to make sure that I was right. And we can see that the normal line goes perfectly perpendicular to the function at that point, negative 1, 9. So let's see, Tarek and Ahmed, do you see where you went wrong? Ahmed, you didn't get the negative reciprocal of the slope. I think maybe that was your issue. Excuse me, I think that was your issue. Tarek, you multiplied by 3 for b. Yeah, but you still got a 27, which is, let me show you why that went wrong, okay? So I think what you did is you had 9 equals, we'll say negative 1 over 3 plus b, and you said you multiplied by 3, which is fine, because you're removing the bottom. That'll give 27 equals negative 1 plus 3b. Then it's 28 equals 3b. Your problem was you didn't multiply your b by 3. And so when you divide both sides by 3 now, your b comes out to 28 over 3. And that's the difference. You were supposed to get 28 over 3, but you forgot to apply the 3 to the b value. All right. So I'm happy with that. Most of you seem to have nailed it. That's the harder version of the question. Again, on the assignment, I'll very likely be giving the tangent line. On the test, you'll be getting the normal line. But it won't be much harder than this. In fact, it won't even be harder than this, I don't think. It'll be similar difficult to whatever ones I've given in this section. Okay, shall we move on to our last topic, and then I'll do some review for the assignment before we finish today. I made a special review for you because I like you so much. Let's do it. Man, my nose is itchy lately. I'm very sorry. I think it's this beard. I think it's time that I maybe shave this thing off. We'll see. So all of these are perfectly reasonable practice. You know, you would change form of this first because we see the constant on top. You want to bring it to the top, and then it's very easy. This one, equation of the normal line, nothing to it. Very straightforward. This one's a little bit more challenging. M is always a fraction. No, not necessarily, Ahmed, because, for example, M could be 3. It just means we go up 1 over 3. It just is a line 3. It could be a fraction. It could be a regular number. It could be anything, really. It could be any number. So don't think that you need to get a fraction. And then here it says, what's the equation of the tangent line with a slope of negative 16? That's a challenge. I wouldn't ask one on the test, but if you want to look at the full solutions online and try to figure that one out, There's nothing wrong with it. I just wouldn't give you that one on a test. So we have one more topic, which is actually physics, which is why I like this topic. It connects things that you've probably seen in physics to things that we're doing in math. And in fact, many of your physics equations can come from what we're about to talk about. In fact, I'll bring that up right now. I'm just going to say, think about this. You've all done physics, right? You all did physics 1100. That's correct, just to be sure. I'm pretty sure you all did physics 1100 because you're all engineering students as far as I know. So in physics, the way that I note this out, you have a displacement is v1 t plus 1/2 a t squared. Okay, for example, that is an equation that you've probably seen many times in kinematics. The displacement is the velocity times the time plus 1/2 acceleration times time. Well, let's get the derivative. Let's get the derivative of this and get d prime. What's d prime? Just treat the t's like an x, okay? So v1's just a constant, so we get the derivative, just like if it was 5x would become 5. If it's v1t, it becomes v1. So we get v1. And then for the next one, bring the 2 down and multiply it. It cancels, it leaves the a, and then the t goes down by 1. So if we get the derivative of the displacement, you're not going to even have to do something this hard. I'm just trying to make connections for you. If you get the derivative of the displacement, it gives you d prime, which actually is v, which you've seen before. v2 equals v1 plus at. So the reason these formulas are what they are is because of calculus. You have your standard position function. If you get its derivative, you get the velocity. If we go one step further and get the derivative, so one step further, get the derivative again, it'll be acceleration. You would cancel this constant term and just leave a. And that's not a useful definition, but at least we can see that it does actually match. Okay, and that works with all of our derivatives. So my point here is if you have a position function, if you get the derivative of it, it becomes the velocity. You get the derivative of that, it becomes the acceleration. So the big takeaway here is our position. If S is position, or displacement, S prime is velocity, also known as V. S double prime is acceleration, also known as A, and it'll be V prime as well. So I'll get to that in a second. So the reason why this works, I'm just going to bring you to 2 quick little things. I'm going to go to this GeoGebra app online, this GeoGebra website, because I found this to be really nice. Let's see if it loads. Okay, so just bear with me now. Ignore the extra stuff. Look at the green line. From physics, you should know that if this green line is position, it means that something is decelerating and then accelerating away, or it's coming to, home. We're going from far away, slowing down, we're ending up at home, and then we're going away quickly. So it's a position where it has an increasing speed, also known as acceleration. In physics, you should know a curved line is acceleration. If we look at one specific point on this curve, look at this, let me draw on this. Let's just say I'm going this way. You're driving. Maybe you're driving now away. If we look at this point here, let me make it a clear color. At this point, if we just imagined, take a picture at that point and said, how fast was I going? That's the tangent. And so if you have the position function, you get the slope, it is the velocity. So in other words, if we have our position function, we just get the derivative of it, and it'll give us our velocity at that point, the exact velocity. If we have the velocity, then the derivative of the velocity is the acceleration. And so that's the big idea here. That's all we really need to know. Okay, so let's get out of this and start working with that rule. Oops, sorry. Sometimes the Zoom tools, no matter how many times I use them, still confuse me. So let me summarize what I just said using the notes. It says the derivative as an instantaneous rate of change. How fast something is changing its motion at one instant. The derivative of a function can be interpreted as the instantaneous rate of change of the dependent variable with respect to the independent, which means if we have s and t, it's just like y and x. Long story short, given any position function s of t, we can find the corresponding function v of t. And the formula is this. The velocity is the derivative of the displacement. For a similar reason, the acceleration is the derivative of the velocity, or the second derivative of the position. Let me show you how easy this is. Okay, if we have any position function, you can get the derivative that gives us velocity. Let's do the first example. Find velocity and acceleration for this position function. So the first derivative, the velocity is just the first derivative. It's 48. Easy. The acceleration, what's the acceleration of this? What's the derivative of 48? 0. We're done. This was the first derivative of the position. This was the second derivative of the position. How easy is that? Isn't that a nice way to end this unit? This is the kind of stuff we're going to be expecting to see now. You're all alive out here? I haven't seen anyone in the chat. Still okay? You haven't run away, have you? I was trying to do that, but I had a pen in my hand. Hey, okay. So, long story short, if you have the position, in this case, this graph, if I was to graph this, it would look something like this, like that. Of course, if this is the position, if they're going at a constant speed, remember from physics, constant speed is a linear, then the velocity makes sense. It's going at a constant speed because it's a linear function. And if you're going constant speed, you have no acceleration. So you don't need to fully understand the extra pencil stuff. You just need to know the basics. But these things should make sense. You're going at a constant speed, walking the same distance away from home every second. If you get the velocity, then it's a constant velocity. And then if you have constant velocity, it means no acceleration. So acceleration is 0. Let's try the next one. What's the velocity? Some of you might have already worked ahead. You just get the derivative. 8t minus 4t cubed. That's our velocity. If we put a time value into that, we'll get the velocity at any time. For example, if time was 2 seconds, then velocity at 2 seconds would be 8 times 2 minus 4 times 2 cubed. And that would be, let's see, 8 times 2 minus 4 times 2 cubed. It would be negative 16 meters per second. So it'll be moving in the negative direction at that point. Just for example. What's the acceleration? Someone tell me so I can know you're all alive out there. It's unusually quiet for this group. Okay, thanks, Aisha. 8 minus 12, 2 squared. So once again, you know, if I was to put in a time value, for example, what if I wanted to know how was this car, for example, how was this accelerating after 1 second? So when time is 1 second, we put 1 in. We would get 8 minus 12 times 1, or we would know he's actually accelerating or decelerating, accelerating in the negative direction 4 meters per second squared. So these are all connecting back to our physics concepts. Once again, velocity is first derivative of the position, acceleration is second derivative of the position. Easy peasy. I'll keep that there. I'll do C. First derivative, 6t minus 6t squared. Acceleration, 6 minus 12t. Once again, yeah, so Ahmed, there's negative velocity. In physics, I mean, physics is applied math. But you're saying in math there's negative velocity, of course, because it means we have a value. The number is how fast we're going. So in this case, we're going 16 meters per second. So you're traveling 16 meters every second. That's pretty fast. And negative means we're going in the negative direction, whatever we called it. It could be backwards. It could be to the left. It doesn't really matter. It could be down. You've done physics. You know that it could be a bunch of different things. But yes, we can get negative values for it. It doesn't make a difference. Okay, so this is how these go. You can put any numbers into these formulas now, and just given the position, you can figure out what the speed is at that point. Pretty cool. In my opinion, it's pretty cool. Let's move on. Calculate the velocity and acceleration of an object whose path is described by this. So it's a quadratic function. Generally speaking, this is the path. They'll look something like this. So it's decelerating. It could be an object. It could be a projectile. It could have been thrown, and it has different speeds and velocities at different times. What's the velocity? Well, 40 minus, what's 4.9 times 2? You'll recognize this, 9.8. You'll notice that this is something we've seen before. S, or position, is v1t plus 1/2 at squared, and then our velocity is v1 plus at. And in this case, our a is gravity. So it all comes together. Hopefully you can see that this is kind of neat. Let's get our acceleration while we're doing this. It's negative 9.8. And we know units, so that's meters per second. You could add that in if you wanted. Personally, I love how this connects physics and math. You have your position function, and as you get the derivatives, we actually see that it's exactly where our physics equations came from. At time equals 6. So when time equals 6, velocity is 40 minus 9.8 times 6. So 40 minus 9.8 times 6 is, I'm going to ignore the fraction now because it's more easy to think of it as numbers. You know, you can think of that as an actual number that your car would tell you that you're going. You can change it to kilometers per hour if you want. And then again, acceleration when time is 6. Is our acceleration with 6 in for t. Well, where's our t? I don't see t, which means it doesn't change. There's no t to substitute. Any questions on that? I did it quick, but they're not difficult. They're fast. Get the derivatives, they'll pop out the equations. Use those equations to figure out your times. Much easier even than our original physics questions last term. So Ahmed, you say no. You're just saying no, right? You're not asking something about number 2, right? Okay. Oh, no, 2. That's T-O-O. Sneaky, sneaky. All right, let's do one more example, and I think the rest are practice. So let's see. Let's read the question, see if we can make sense of it. This is the last example of the notes. The rest is practice. So a projectile is fired upward with a velocity of 44 meters per second. It's shot up into the air. The distance, s, in meters above the ground of the projectile is given by this equation, where t is in seconds. So what's happening here is we have a projectile that's been fired into the air, and then it comes back down out of the air. So really it goes up and then it comes down. But if this was a graph, if we were to graph this motion, sorry, I'm thinking of ways to explain this. If we were to graph the position over time, why does my computer do this to me? It would look like this. It's a projectile, so it looks like this. You remember this from physics? It wasn't that long ago, I'm sure. You have a projectile. That's why it's written like this. It's quadratic. So that's the equation where t is in seconds. Find the time when v equals 0, or in other words, how long it takes to reach maximum height. Okay, so we have a totally different way of thinking about something you did in physics already. First of all, what's the velocity? It's the derivative of the position. So instead of having to do all the stuff we did with physics, you know, where you set time equal to something or set the maximum height equal to something, you just go ahead and do it. The derivative is 44 minus 9.8t. The question is, find t when v is 0. So when v is 0, what's t? That's our question. So let's substitute it in. When you see your v, make it 0 and solve for t. 0 equals 44 minus 9.8t. That means negative 44 over negative 9.8 is t. So what's that? Negative 44 divided by negative 9.8 is 220 over 49, but this is in seconds. You know, it's more like physics now, so we can use our decimal answers. But if you wanted to give it as a fraction, it would be 220 over 49. And that is how we do physics in a math class. Questions, concerns, problems? No one. I think it's easy too, but it's very difficult for me to actually figure out if it's easy for everybody. All right, so that's how she goes. I'm going to graph it, and then I'll do our review for the assignment, okay? Let's see what she looks like. Let's make the connections. We have s equals 44t minus 4.9t squared. So this is our motion. Let's squish it down. This is our parabola. I told you it was a parabola. That's our motion. We shoot something in the air. So Jocelyn, you just asked on Thursday, do we have a test too? By the way, nice to see you, Jocelyn. I haven't seen you in probably ever. We do not have a test on Thursday. We have a test on Sunday. Okay. So this is our projectile. I can even move it so that we can see it more clearly. And I want t when v is 0. So when is t 0? So that's our top point. That's at its maximum point. That's when velocity is 0 because it's at the maximum. And you'll notice that the time is exactly what I'm saying it is. Time when velocity is 0, which is at the tippy top, 4.49. And yes, there's an assignment tomorrow, Ahmed. Yes. So this is all matching up. You'll also notice that the slope at the top is 0. which is why when we look at this, velocity is zero, velocity is slope, all these ideas get connected. But you don't need to know the extension stuff. I'm just trying to help you understand why all this is important. All you need to know is what I've done on the page, as always. I just like to give you a little bit of background so that when you move on, you've got some things in your head to think about later. Who knows, maybe you'll thank me down the line when you're some famous engineer. Who knows? Let's do some practice, shall we? We've done this example. I don't think we need to do these practice. They're all basically the same. You would get the derivative of this, chain rule. Just as a reminder, you would change form. And you would do the chain rule. For this one, this is a bit of a challenge, but this one's not bad. Just get the derivatives. Same thing, get the derivative. Sorry, I was just reading your question. All of these are pretty much the same. So you can check the full solutions on that. Ahmed just had a question and said, can the question say find t when the object is at maximum height? I could ask that because at maximum height velocity is zero, and you would be able to infer from that. But because this is more math focused, I usually don't. I try to make it more obvious. So I wouldn't expect that, although maybe as a bonus that would be a nice idea. But no, I'm not going to ask it as a standard question. Good question, though. It's just good thinking. So if there's no other questions, which it doesn't seem like there are, but you can always let me know, I've made a assignment practice. So I took some assignments that I've had in the past, and I made a practice assignment out of it so that we could go through and review this topic. So that's what we'll do for the rest of the next hour or so. I haven't posted this on D2L. I might post it on D2L. I should have posted it earlier, but I've been really busy with the move. So that's my excuse here, sorry. But hopefully you have a notepad. You can do these examples. You'll be able to look back on the video, and I'm going to post these solutions when I'm finished, okay? So you'll have a nice, concise way to review some of the concepts. Or at least you'll have a practice example for what I've done. Let's get started. This is the start of review. By the way, if you don't want the review, no, never mind. This is the limit as x approaches -1 of the function. So we need to look and see what the answer is, of course. Where is x equals -1? This is x equals -1. What's the limit? What's the limit at that point? You know, if you imagine going from the left and from the right, just graphically, looking at the graph, what's the limit going to be? It should be very clear. The limit is going to be 1. The limit is 1. Do we remember that? Maybe I'll make it in a different color so that it's clear. The y value is 1 at that point. It's 1. That's it. The limit when x is -2. Let's make a different color, green. When x equals -2, what's the limit? Is it 1? Is it 2? Is it 3? Is it 0? Is it -1,000,000? So far you're both wrong. Anyone else have any guesses or any thoughts? Well, let me remind you. As x approaches -2, which is this line, that's the line x equals -2. It goes to positive infinity, and it goes down to -infinity. If it's up and down at the same x value, the limit does not exist. I'm glad I did this review. So this is the time of the day where I want you to just type anything in the chat. Just type hi, or type 1 or 2, doesn't matter. I want to write down who is still here, because once again, I've been told to take attendance a little bit more closely. So just type hi. Hello, 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 hello. Hello, hello, hello. Almagi, Yasser, Hussein, Juma, Aisha, Abdullah. Let's see who else is here. Rania, Tarek. And I think that's everybody. And so this is the fun part. This is where I go through and remove people. Yeah, I saw you. I've been told to remove them. All right. Let's see, who else? Anyone else? Let's see how that works out. Hopefully I didn't just remove someone that didn't reply. Okay, let's keep moving on. Evaluate the limit of this function when x goes to 3. So let's try direct substitution. So let's try direct. That means 2 times 3 minus 6 over 3 times 3. That's 6 minus 6 over 9, which is 0 over 9, which is 0. Nothing wrong with that. You're allowed to have a limit of 0. It's not a problem. So that one was a direct substitution, very, very simple. Let's try this one. Direct. Oops. Direct. Let's try it. Let's try putting in 4 whenever I see an x. So that would be a 4 squared, so 16, plus 16 minus 32 over 16 minus 16. That's 0 over 0. Doesn't work, just like Tarek said, it doesn't work. So what do we try next? If direct substitution doesn't work, what should we do? Well, let's try algebra, factor. Let's factor the original expression. So let's say the limit as x approaches 4. Factor the top. Let's factor the bottom. The top is x and x. 32. What are the factors of 32 that multiply to make 32 and add to make 4? Well, you can have 1 times 32, you can have 2 times 16, you can have 3 times, is 32 divided by 3? No, 3 doesn't work. 4 does. 4 times 8. And that's about it. 6 doesn't work. 7 doesn't work. So these are our possibilities. Which one, when you subtract them or add them, makes a 4? Well, not this one. Not this one. It must be 4 and 8. And the sign, the final sign is negative, which means they're 2 different signs. So you should work out that this is a positive 8 and a negative 4, which is exactly what the 2 people did. Gossam, you said, can we do derivatives? Well, what do you mean derivatives? We wouldn't do derivatives for a limit question, unless you have another idea. Can you explain what you mean when you say, can we do derivatives? Do you mean you want me to review derivatives? Yeah, I'm getting to that. We're going in order. So the bottom, we want the square of x, which is of course x. We want the square root of 16, which is going to be 4. So that's difference of squares, plus and minus. All right, now we're getting somewhere. Cancel. We end up with limit. X approaches 4 of x plus 8, x plus 4. Now we can direct substitution. We have 4 plus 4 plus 8, which is 12, over, let me write the whole thing just in case. I don't want anyone getting lost. So this gives us 12 over 8, also known as 3 over 2. Thanks, Aisha. So if direct substitution doesn't work, try factoring. Usually that's your method of solution here. That's if we have 0 over 0 form. All right? Make sure you know how to do basic factoring too. Just check your factors and see which ones multiply to make the third number and add to make the middle number. Let's do limits as x goes to infinity. We have a nice rule for this. It almost always works. First of all, if we divide this, this would end up being infinity over infinity if we would do it directly. So we don't want infinity over infinity. What do we need to do? What's our strategy? Divide by the highest power of x in the denominator, which is x squared. So divide everything by that. So I'm going to rewrite it. Limit as x approaches the infinity, and I'm going to divide everything by x squared. So you're getting 3 over 2. Let's see what we get. 3 over x squared minus 2 over 1 plus 3 over x. If we do the limit now, as x goes to infinity, this is divided by an absolutely massive number. This is divided by an absolutely massive number, so they go to 0. What we end up with is negative 2 over 1, which is negative 2. So 2 over 3, or 3 over 2, yeah, was for the previous question. Sorry, I was looking in the chat. I was like, why are they saying 3 over 2? Surely that's not right. This was our answer. I'm just going to space this out a little. I don't want you thinking that these ideas are connected. Okay. Any questions on that? So if we remember, if you have infinity over infinity form, almost always this is your strategy. If you have it going to 0, the strategy is slightly different, okay? Let's see what's going on here. If you need me to go back to this, I will. Number 5, let's evaluate the limit. So if we do direct substitution, let's direct, what would we get? We would get 0 plus 5 over 0 squared, which is 5 over 0, which is infinity. So that's not, I don't know if that's necessarily what we're looking for. Is that okay? Like, is that okay? What happens if we divide by 0? So when I said we divide by 0, I suggested that you just graph it, and it can lead you to the answer. So that's what I'm going to do. I'm going to graph it and see what the answer is. We have x plus 5 over x squared as it goes towards 0. Oops, I didn't mean to delete that. what happens as we go towards 0? It's going from the left, it's going up to infinity. From the right, it's going up to infinity. So actually, this limit exists. It's positive infinity. And I gave you a few different ways to figure that out. The main idea, the main suggestion that I said when it goes dividing by 0 would be to graph it. And you can see that around the point x equals 0, it goes to infinity, positive infinity. And as long as those are in agreement, it's okay. Ahmed, you're saying in limits, any number over 0 is infinity? Yeah, pretty much. That would be your shortest way to do it. Let me write it out more clearly why it works. Remember, it's going to 0. We're actually not dividing by 0 itself. We're dividing by something very, very close to 0. So we have, essentially, we'll say 5 on top. On bottom, we have what would be a tiny, 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 tiny number squared, which is still a tiny, tiny number. So I'll put the square back in. What's 5 divided by 0.0000000000001? You know, 0.00000000001. It's trying to get as small as possible without being 0. If you set that up, 5 divided by 0.000000001 squared. I get 5 times 10 to the power of 30, which is like 5,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,00,0,0,00,0,0,00,0,0,00,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0,0with 30 zeros, right? It would just get massive. It goes to infinity. So the answer is infinity. Long story short, if you have things that are in 1 over 0 form, it becomes infinity. That's all you really need to know out of this. Of course, I said a lot more than that, but that's your shortcut. If you have 1 over 0 form, it's actually okay. It's going to be infinity. If you have 0 over 0, it's not okay. If you have infinity over infinity, it's not okay. It's 1 over 0 is okay. Before we move on, is that clear, or do I need to review anything? I can give another example if you need it. Okay, so again, if you need more examples, you can honestly just look back in the notes and try a few of the practice. So use the definition of the derivative, also known as the delta process, to determine the derivative of this. This is our delta process, so it's even being nice enough to give us the formula in the question. I'll do the same thing on your assignment. Let's do it. Let's do this. The limit as x approaches h of f, but we've replaced the x with x plus h. So x plus h squared plus 6 minus the original function. Put in the brackets, please. These brackets are absolutely crucial, okay? Just in case you're a little lost, I want to make sure that we're all clear. So I'm changing the colors here. F of x plus h, let me make 2 different colors. F of x plus h, that's this, minus f of x, that's this. I want to be very clear about this. If you don't use your brackets, you will not be able to get this. Easy as that. Because we're subtracting the whole function. So if you're subtracting the whole function, that minus sign is going to be distributed. It's going to be multiplied by everything. And now, of course, all of this needs to be divided by h. That's the hardest step, in my opinion. And now we just follow the same process as we always have. So, by the way, I'm going to do my check right now. Let's check. What is our answer going to be? Look at this. Tell me what's the answer. What's the derivative? What's the derivative of this function? 2x. That's our answer. So we go through the delta process. If we don't get 2x, we've made a mistake. So let's go through the delta process, see if we get 2x. So I'm going to expand the first one. That's x squared plus 2xh plus h squared. You should be familiar with that by now. You should know that this gives this. What else? Plus 6 minus x squared minus 6. That minus is because it gets distributed through, all right? Don't lose that or else it won't cancel. Now we can cancel things. Positive x squared cancels with negative x squared. 6 cancels with negative 6. Now I'm going to factor out the h. I have h, that's I have 2x plus h all over h. I'm going to cancel those, and now I can do direct substitution. I'll keep in the step so that it's clear, but really I could jump straight to the answer now. I'm going to directly substitute this. This is 2x plus 0, or in other words, the derivative is 2x. All right, that's how this works. We know that that's the answer because we can do our shortcut. The delta process, if you do 100 of these, you'll see that the pattern comes out. The reason the power rule works is because someone very smart or very bored did many of these, and they saw the pattern's always the same. The power comes down, and it keeps the inside the same. So that's why the power rule works. Anyway, this is the delta process. I won't give you one much harder than that on the test or the assignment. And there will be one on the assignment. So this is your hint. You should expect a delta process question on the assignment tomorrow. So Tarek, yeah, I can explain the first step. What I would like to remind you, I'll just make a little side note here. Let's write out two things. F of x, our original function, is this. All right? I haven't changed anything. I just copied it there. What if I wanted f of x plus h instead of f of x? Because our formula needs it, f of x plus h. Well, anytime I see an x, I would make it x plus h. And that's our function, f of x plus h. So that's what I put in that first step. Is that okay? More clear? All right. No problem at all. That's what I'm here for. And some more students have been coming to me and asking me for help in outside hours, which is great. I love to get questions because it just means that you're doing the work. I appreciate that. All right, we've got the definition of the derivative covered. Let's see what else we have in store. Maybe direct derivatives, maybe product rule, gross rule, chain rule. Hey, look at this. Determine the derivative. So let me zoom in a little bit. All of these, power form, almost power form, we can do this. This is 2x to the 1/2. Now I can do it. So let's do the derivative. 10 x to the power 4 minus, let me add a little piece here. What if this was plus e squared plus pi plus cosine of pi? I'm just going to add a little bit to the question just to make it more interesting. So we have 7x. What's the derivative of 7x? It's 7. Just deletes the x. What's the derivative of 2x to the power of 1/2? Well, it's 2. And then the derivative of that is 1 over 2 x to the power of negative 1/2. The rest is What's e squared? Well, e is just a constant. Doesn't matter if it's squared. It's still a constant. So it's 0. 2 pi is just a number. It's just a constant. So it's 0. Cosine of pi. Pi is just a constant. So it's 0. So this is something that tricks students. So I wanted to write it in. E squared. Yes, I can go up. E squared is a constant. 2 pi is a constant. You can put it in on your calculator, give you a number. What's 2 times pi? 6.283185307. It's just a number. You can even put e on your calculator. Just go alpha and then hit the times 10, hit the pi button. It also gives a number. It's just a constant. So I just wanted you to know that. So let's simplify this. 2 and 2 cancel. So our final answer is 10x to the power 4 minus 7 plus 1 over root x. It's okay? Excellent. What do I do for 7b? What's my rule? Product rule. Product rule. So remember what the product rule is. FG. Derivative of the first one, derivative of the second one. Add them together. P prime of x is the derivative of the first one. What's that? That is, and use the brackets. If you use the brackets for every single piece, I mean this, you should have 4 sets of brackets. You will not get this wrong as long as you can get the derivative. So f prime is 12x cubed minus 3x squared. -1 is a constant, so I don't touch it. Keep g like it is. Plus f multiplied by the derivative of g. Derivative of g is 12x squared plus 2. It says very clearly, do not simplify. And so I'm done. How do I get 4 marks for this? Wow, 4 marks seems like a lot. Well, 1 mark for the derivative, 1 mark for this derivative, 1 mark, I don't know, maybe it should be worth 3 marks. It seems like a lot before. But 1 mark for using the product rule. And I think 1 mark for all of it being correct. I'm not sure I'll make it 4 marks. It's more of a 3-mark question, but 1 mark for effort. Yeah, 1 mark for breathing. And yeah, as long as you want 4 marks because it's easy. It's okay. I'll have it 3 or 4, no more. It's really a 3-mark question, but maybe I'll make it 4. We'll see. We'll see what happens. I'll give you a little hint. I'm putting a bonus question on the test or on the assignment. First bonus question. So that should be interesting. Let's do C. What's our rule? We have a big old function on top, a big old function on bottom. Some might call it f and g. That I would call the quotient rule. And if someone were to ask you what the quotient rule is, it looks a whole lot like the product rule. It has a minus and a fraction and a g squared on bottom. We just need to put our pieces in. It says g of x. That's a little confusing because the quotient rule has a g in it already. But don't be fooled. They're just 2 different g's. I'm going to call this g prime. Still follow the same rules. So the derivative of the top, 2x plus 2. The bottom stays the same. Minus, not plus, the top. Now the derivative of the bottom. And don't forget to get the bottom squared. Do not expand it. And another thing, the bottom is this. Some students just do that. They just write a square next to it, but that's not right. Of course, you need to close the brackets. So make sure you do close the brackets. And notice that the square, many students forget the square. I don't know why. So I'm just going to say, don't forget me. Don't forget me. Jack, I'll never let go. Let's go. You know what that reference was? Anyone? Anyone get the reference? No? No one? Is 1997 too long ago? Titanic. Come on, Titanic. I can try. All right, that question's done. Why is it done? Because I said do not simplify. If it says don't simplify, don't simplify. It would take too long. How's that? Is that an easy enough question? Do you want another one like it? Should I move on? How do we feel? Kenneth says it's easy. Move on. Move on. Move on. Yeah, this is the final answer, Ahmed, because you've done the product rule. You've done the quotient rule. You got a derivative, you got the other derivative, you use the quotient rule in the right way, and everything's correct. So your 4 marks, we're finished. Don't simplify. If you start expanding things, it's going to be huge to no benefit. There's no advantage at all, so we're done. Find the derivative of the implicit function. Why is this called derivative? Why is this called implicit? The fastest way to know, yeah, it has y, but not just that. It's not already solved for y. It's not y equals. We have a y in the middle here. And so we need to just deal with it as if it's a function of x, which means it's going to give us a y prime. So hopefully you remember the steps. It's just get the derivative and then solve for y prime. Let's do it. 15x squared plus. Anyone remember what I do now? My cat just made a very loud noise. The next step is product rule, PR, excellent. Derivative of the first one times the second one plus the first one times the derivative of the second one, y prime, minus 9y squared equals 0. Tell me what I did wrong. Tell me what I did wrong. Tell me what I did wrong. I expected a million people to tell me. What did I do? What's wrong? What happened?
You put more on and y. You put one more y.
Another y prime. Right here. Many students miss that one. Because you need to think of it like a chain rule. You need to if it's 3y to the power of 3, the 3 comes down and gets reduced by 1, but you also get the derivative of the inside. So it's chain rule. So what we end up getting is 9y is reduced by 1. Many students leave it like that, but the derivative of the inside is y prime. So just be careful, be very careful with this. Anytime you get the derivative of y, When it's implicit, you get a y prime. Let's move everything to the other side. I'm going to do it in one big step. Factor y prime outside of everything that has a y prime term. It looks like this. Bring everything else to the other side. We'll end up with a negative 15x squared minus y, and then divide it all by the term next to y prime. If you need more steps, just compare it to the stuff I did in class. I showed all the steps in class, but I wanted to show you that this is not a long question. It just seems long when I show you every single step. Questions? We're almost done this guy. Can I explain it again? Which part? So the main steps here, let me go bit by bit. 5x cubed, I'm sure that that's clear. The derivative of that, 15x squared. I don't need to explain that, I'm sure. This second step is a little bit tricky because we have a product rule. We have the first function, we have the second function. So this is the derivative of the first one times the second, as it is. I probably could have left brackets off of that, actually, and that's what I'll do. Y. And then we have the first one times the derivative of the second one, but the second one is just y, so the derivative of y is y prime. That's our product rule. And then when we have to do the derivative of this, I already explained that one. It's the derivative as if it was x, and then it pops out a y prime term, because y's always have a y prime. So that's the first step. Ibrahim, you're asking for the second part. So what I'll do is I'll add in a step. What I did two things. So hopefully you're paying attention. I brought anything that didn't have a y prime term to the right side. And so I'm going to have on the right side a negative 15x squared and a negative y. That's this one, negative, and this one, negative. That's what happens, of course, when we bring it to the right side, or the other side. You'll notice that this has a y prime and this has a y prime. So I'll just write those out. This is x y prime minus this. Hopefully that's clear. I probably should have written that in pencil to be consistent, but whatever. Let me write the rest in pencil. I might as well add this as an official step. Okay, now we've got our values. I'm just going to shift this over. Sorry to move everything around, but when you look back on it, it'll look better. Trying to match everything up. You should see that I went from this step. I factor the y squared, y prime out, and I ended up with these. If I factor out a y prime of both of those things, I end up with these left over. It's like dividing the y out, the y prime out. Is that more clear? Anyone else have questions on that? That's what I get for skipping steps. Next time I won't skip steps. I don't know why I thought it was a good idea this time. Ahmed says it's good. Hopefully it's good for all of you. So let's see, equation of the tangent line to the curve. All right. Let me interject. This is actually, I think, the last question. Yeah, it's the last question. I'm going to add in a little extra example just on the side. It's really practice. So let me just say practice. With the chain rule. get the derivative. If this is our function, what's the derivative? Okay, that's our question. How are we going to get that? Well, we can rewrite it, and you should rewrite it. And as soon as you rewrite it into power form, is what I usually call this, the rest follows pretty easily. Just make sure you change the square root into a power of 1/2. Once you do that, we can get the derivative by our regular methods. Take the power down in front, 1/2. Keep the inside the same. Reduce the power by 1, which you should be getting really good at by now. Just 1/2 minus 1 is negative 1/2. So our blue parts here are what I got from the power. And then many students leave it here. And I don't quite know why. I think it's because they don't understand the chain rule. You need to get the derivative of this. So the derivative of the inside, what's the derivative of 6x to the power 4? Oh, it's 24 x to the power of 3 plus 7. And many students leave it here. There is one last thing you actually need to do. Remember, you're multiplying by the inside. Am I multiplying by the whole inside now? Actually, no. It's only multiplying these two things together. This thing is all on its own. So what we need to do is use brackets. Just a little example of how we would do a basic chain rule question. It's not on the practice here, but I would expect it on your assignment. We've done ones like that before. All good? 10 out of 10? Would math again? 11 out of 10. Would math out of 10. Would math again. I don't know what I'm talking about anymore. I'm sorry. All right, I'm going to take that as a yes, and I'm going to move on to the final question. Because this is the last question we're going to do before I actually get any feedback from you, I would like you to get the answer yourselves. So take 5 minutes. Tell me what the equation to the tangent line is. Let's see if we can do it. This will be the last question of the unit, so put all your energy into it. Try to get off on a high note. So the question is to give the equation. You've given the number 96, which is not going to be enough. Yeah, it's wrong. So once again, it's not a number, it's an equation. So maybe it's time for me to help you out. Let's see what the steps are. Steps are that we need to get the derivative and we need to sub in x equals -2, because that's our regular steps. Let's get the derivative first. And of course, if you're still working on this, keep working. Nothing wrong with that. The derivative is just like what we just did. It's the chain rule. So bring the power down, keep the inside the same, reduce the power by 1, and then the derivative of the inside, and use brackets. Derivative of the inside is 6x minus 4. That's our derivative. It was actually much easier than I thought it was going to be, so I'm going to bring this back up. Now we need to substitute in the value x equals 2. Why do we do that? Because we need the slope at the point x equals 2. So the slope of the function, also known as the derivative of the function, is this. So this will give us our slope. It's going to be pretty big. I might show the graph later, depending on how much time this takes, and show you that it's very steep at that point. So I think it's going to be a big number. The derivative is going to be, and I'm going to put this into my calculator exactly like I see it, because I don't want to miss anything, but I also don't want to do it by hand. Bracket, bracket. Be careful with your brackets work. Minus 4. I get 384. Did anyone get that far? Oh, you multiplied 6x and 4, yeah. Be careful with that. Forgot the square. I'm assuming you're talking about this square. That's a really common mistake. Yeah. A lot of students bring down the 3 and they're like, see ya. They don't put the square in. That's why oftentimes I'll bring the 3 down and make the brackets and immediately put the 2 up top, because that reminds me that there's a 2. Because while you're copying out the inside again, sometimes in the back of your head you don't remember what you were doing in the first place, which is actually the power rule. So many times that's what I do. I'll take this 3, bring it down, and I'll do this. And then I fill in the inside. And that keeps you from missing it. Just a little piece of advice. So we have our derivative, we have our slope. The slope is not the question. The question is find the equation of the tangent line. So the third step, and the most important step really, is to use y equals mx plus b. We solve for b and then we substitute it in. So in this case, our y value is 64. This is my x and my y value. So I'm going to say 64 equals 384 times 2 plus b. So what's that? Those are weird numbers. 384 times 2. That's -684. And my final answer, y equals mx plus b, y equals mx plus b, so minus 684. Okay, mister, in his case, he gets 0. Can you be more specific? You mean if Abdullah was to do the derivative wrong and forget the square, would I give him 0 marks? Is that what you're asking me? No. That's not how I roll, and you know it. Whether this is physics or math, doesn't matter. I think that students who are doing the work and following the steps should still get the marks. So what would happen is I would take away a mark for missing the square, and then I would tediously and annoyingly and sadly go through all the steps and say, okay, did he substitute x? Yes. Okay, what did he get? Did he get m okay for his numbers? Yeah, okay, he gets a mark. Did he try to use y equals mx plus b? Did he put all his numbers in? Okay, then that's correct. And then maybe in the final answer, because it's not actually the right line, I would probably take another half mark, maybe. Sometimes I don't. But at most, he would lose 2 marks, but honestly, he'd probably just lose 1 mark, maximum 1.5 marks. Because I have a heart, and if you're doing so many steps that you know what you're doing, but you made a small mistake at the beginning, I don't think it's fair to take away all the marks. Why is the sad face, Abdullah? Too many marks taken away? Well, it doesn't matter, Abdullah, because you're not going to make that mistake on the assignment now. So we don't need to worry about it. All right. What if I ask for the normal line as an extension? It would be very easy. We just change the slope. So we would say the normal line is -1 over 384. And we would do 64 equals -1 over 384, 2 plus b. That would give b of this. And then we would have our final answer. Oops. All right, so that would be our slope. So Tarek, you said y is -1 over 384. It's actually the slope. So m is -1 over 384. So this is the last thing I'm going to graph and the last thing we're going to do in the whole unit because I finished the review. I just want to graph this to make sure that what we did is correct. So the original equation is y equals 3x squared minus 4x power 3. Whew, what a function. So it looks like that. It's kind of a crazy looking function. Our point is 2 and 64. Okay, so it's on the line, that's good. And if we look at this function, I'm zooming in, we can see that the function is very steep at that point, which bodes well for our slope. Our slope is 384. That's super, super steep. So let's see if our our equation is correct. I certainly hope it is. Minus 684. That's our tangent line. Wait a second. It's not the same. not the same. What have I done? Let's see if I can find my mistake. So I'm going to go back. It's a good teachable mode actually. I'm pretty positive that my derivative is okay. This is okay, this is okay, this is okay. All right, I'm gonna try putting in my 2 again to see if the slope is okay. I see the problem. So that was okay. The problem was here. B isn't 684, it's negative 7/704. I'm gonna rewrite that after, okay? So be careful. I made a mistake. It's negative 704. Let's see if that fixes this graph. My final answer should be minus 7/4. Now we've got it, okay? So this is why graphing is a really, really good way to check your work. You've got your original graph, you put your point in and see that the tangent goes through it. And in this case, it does. I'm going to graph my normal line and hope that this is less issues. Negative 1/384 x plus 24577/384. And that looks about right. There's something a bit weird about the scaling, but I think it's actually okay. Yeah, it's my tangent and my normal line perpendicular to each other. So I think I'm okay. By perpendicular, remember I mean that the tangent line and the normal line are 90 degrees between each other. Khalas. I've conquered it. We've conquered it. Let's go. I'm going to change this answer key so that no one watching this later gets too confused. This is 704. But the rest was fine. Okay, so this is your chance to ask any other questions. We're finished the unit. This assignment is a really good summary of everything we've done. Of course, I'm not going to give the same questions. Everything will be changed. But the basic concepts are all covered. Do you want me to go through any of these types of examples again? Or how do we feel? Here's your chance to let me know. Anyone still alive? I'm just static. All right. So let me know before the assignment if you need me. Other than that, it's been real. Tomorrow, the assignment, I might actually just have it go for an hour. So what I might do is, I haven't decided. I think tomorrow we'll do the assignment. I'll send a message. I haven't decided yet. I think maybe a half an hour review if we need it. And I'll start the assignment 30 minutes into class, maybe. I'll decide that after. But for now, we'll stop the recording